Uh, just a quick kind of a recap, just for 2 minutes, what we discussed yesterday. Um, probably I just want to hear out from you. Even it is wrong, don't worry. What is your understanding so far? All right, anyone can start, or probably I will just call Karthik. What is your understanding so far? What is your DBT? Anything is okay. 1, 2 lines, whatever you know, even definition is also okay.
Just 1 second. DBT it's like a ETL, like a T for transfer, sorry. DBT is like a data build tool, and when it comes to what is DBT, like that, uh, like in this DBT we what we call T stands for transformations will be done in DBT, and we cannot load the data, and we cannot transform the data from here like that. I got
Okay,
to know, and
fine.
yeah.
Okay. So, Sudhir, what's your understanding? Anything, as I said, anything is fine. Just 1, 2 lines. What's your understanding from yesterday's session?
Yeah, it seems, Raju, as Karthik said, DBT is a data build tool, and mainly the functionality of the data build tool is only transforming the data, and it sits on our data warehouse and transform the data and load it on data warehouse schema, from where we can use the schema for visualization or data analysis.
Yeah, perfect. So, how about you, Bharat? Any points you want to add, or
Yes,
what's your
Raju. Yeah, it's a DBT tool, the data build tool. Instead of loading the data in this process, it transforms the data from within the extract file. Like in other Informatica Scala, in which we have that like extract, transform, and load. But whereas in the DBT, we have extract, load, and transfer.
Yes, very good. Yeah. Yeah, Hari, what's your understanding so far?
Uh, Adding to that point, so it is not a BA tool, first of all. So in this one, we will do the only the transformations, not extract and load of the things. So by this tool, we can do version control also.
Yeah, very good. Super. I think good. Yeah, I think what you all said, everything is perfect. So that is what we discussed. So features, high level, we discussed what is the basic difference between, we discussed means, what challenges, and how actually DBT is addressing some of the challenges, and what type of DBT products we have, and what is are the key differences between traditional ETL tools and DBT. And high level, we also discussed DBT architecture, where actually DBT sits in our data pipeline architectures, and what are the kind of uh, what uh, features are powerful for DBT, right? So those kind of stuff we discussed, and also kind of very high level details what about DBT. So good. Today we'll discuss a few more concepts. As I said, this would be a kind of, then the next 4 sessions would be labs. So I will just touch upon a few concepts today, right? So you're able to view like this also, right? Because or you want full screen. Anyway, it's okay. So the some of the core concepts, like there will be some configurations, DBT, where the first one will be a DBT project.ml file. This is the ML file, so where we define some configuration details about that particular DBT project. So it is a DBT underscore project ML file. One file we need for each and every project. So every project in DBT needs that DBT underscore project ML file. So basically we specify means directory and path details like models, snapshot directory and all. So during labs we'll understand anyway, but just to show you, yeah. So this is how DBT underscore project ML, and there will be packages dot ML file. So these are the two ML files, and this is the file structure where all the details will describe in ML file. Okay, so the other concept is DBT packages. It is nothing new in this where we provide all the details and packages ML file just we are seeing. It's mainly tell us about what libraries or what standalone project in DBT called as a packages. Okay, so it's more of reusable code where will be there. It's mainly for our maintenance, easy maintenance and data pipeline scalability, right? Because of this DBT packages, we will be able to scale out data pipeline easily. Definition wise, it's kind of collections of macros and models. This is how we will get DBT package. As part of the DBT package, we will get that models and whatever, right? We kind of directly use that models from the DBT package. So there will be multiple packages, but there will be in general means this DBT underscore etools is the package where we would get most of the features. But because it is a DBT is open source, some people kind of they also develop some packages. So if we are working on that particular features or probably additional use cases, we can just get that package and we can install. To give you example for DBT packages like reference function, this get from DBT package and pivot columns, some kind of a pivot, right? Where in some use cases we would have this kind of requirement where we need to do pivot columns. I think Hari, if you remember, we got that requirement in Snowflake also, right? We had that challenge. Right,
Yes,
so
yeah.
this kind of easiness we get by using this DBT packages and create surrogate key means it is kind of unique identifier where primary key is not available, right? By using this hash or MD5 kind of techniques, these packages will generate surrogate key as well. So these are more kind of configuration details, but every DBT project, I mean, will have this project.ml and packages ML. Okay, so moving on next, sources. This is again another strength. Just think in this way. Suppose we are working in a project where you have so many sources. You have a data model, right? You have suppose so many tables you created and your reporting team are using your tables, smart tables or whatever, right? Just take the one scenario. If your data governance team change source and schema names for some reason, right? So how tedious process if something is changed at source and schema name, then you need to go to each and every table. You need to really change, right? So that's really a very it's kind of a very problem if that scenario occurs. So that's what DBT come up with this source model. It's not model, I mean, it's kind of a source concept where we define source.ml file. Okay, so where we describe all source details, where you will mention all raw tables, data and everything like database, schema, tables. So you will use that as a reference in all of your models. So what it means, suppose if you are creating some tables in your data model, you will just use that source as a reference. Means suppose just to give you example, we define source with database schema table details, and from now onwards you will use only just reference, select star from that source name, right? So to talk about this problem, suppose we are in an environment where data governance team change that source schema name or table names, right? Only just will go and edit in source file. That's it, done. Because all other models, we are just using source as a reference. No need to change anything in your downstream models. So that is the advantage. That is the kind of a problem where we are able to address by using this source concept. The other also benefit we get from source, you also can do configuration kind of source data, right? Source freshness. So you also can do that. Just to show you again, I will just go there. Yeah, source.
So in source file, are we going to use any data loaders if we are joining two different sources like Snowflake or Oracle?
It's for us because source means wherever your data reside, right? As we discussed, I mean DBT will not load anything because source data is already there in your Snowflake, right? Either it can be Oracle data or anything. The data is coming from multiple sources. It it's it is stored in your data warehousing. So what details what we are going to give in source, it is all database detail and what is that schema, right?
Schema,
So
okay.
if you change anything, only one place you will change. So I think I don't have source file. Yeah, I think, yeah, this is how it will be. So here, right, you kind of define like this is the source ML file where you will define, you will give details like Snowflake database schema, what are the table names, orders, and whatever, right? Column names. So one time you define source file like this, then onwards, whatever that source name, right? Suppose you will just use as a reference. Means if suppose database schema name is changed later point of time, you just come and edit only in source file, but you need not touch any of your models. That is the advantage. Suppose if you have 1,000 tables or 1,000 models, right? So you need not really go and change table name in that model or tables. Okay, so that is the advantage.
Okay.
Then the other concept is materialization, where this is kind of we define in dbt underscore project ML file. This materialization means it is a kind of a DDL statement. How dbt tool use that DDL statement when we are creating models in warehouse, because you just give some small piece of code, you will not really create table and all, you need not give, right? Because that's what we discussed. It is a kind of very simple coding we need to do. We can just skip a lot of things. So where your dbt tool will understand what you are trying to do, whether you want to create a table or you want to create a view, it will understand by seeing your materialization definition. Okay, so that's what it is. It's create DDLs and just examples for materialization. One is table, the other one is view or incremental. Incremental, I will just tell you what it is. So by default, DBT create models as views, because views you have advantage, right? Some kind of space, then obviously cost, but we need to see whether views, is it okay based on our data model or our kind of project requirements, because sometimes views might have performance issue, right? So we need to really decide what actually it fits to our data model, right? So that's what we need to assess, what actually better fit for us, whether table or view. But by default, DBT creates views. Incremental strategies means it's kind of a delete or insert data, means it's kind of a refresh the data, right? Or probably merge. I think Harish maybe knowing that merge is the one concept in Snowflake. Not sure others knows that. So this is how DBT also use that incremental strategy: delete, insert, or merge. Okay, so this is how Materialization will define a small piece of code.
Nothing but merge statement.
Yeah. Means it will use that incremental strategy if we are just defining that model as incremental. Okay, so whatever we are just doing in merge, right, in Snowflake, because if you want to do only just want to see the delta data refresh, right, in Snowflake will use merge. It will kind of check whether any records got changed or any records got deleted. That's how the merge will work. So same concept or same strategy will be used by DBT as well for this incremental model. So we'll just define, as I said, I mean, if we are not defining materialized, it will just take default as a view. Otherwise, we can define for each and every model what should be our materialization. It can be table, or it can be view, or it can be incremental. So this is how kind of two examples where you will understand how we will just define materialization. Okay, so let me see any there. But anyway, while doing labs, we'll know what is that materialization. We'll understand better actually once we started labs. Okay. Okay. So that's about materialization. Let me move on to then models. This is again kind of another important in the sense kind of a so each model lives in a single file, means if we're just defining one model, we need a single file. So basically what models means, every model will have that logic to do the transformation. So we as a developer or as an architect, I need to define how my model should be, right? How my project, whether it's a so complex project or whether it's medium, what's actually purpose of my transformations? Why do I need transformations? What should I do with those transformations? So based on that, we need to define models how it should be. So there is no rule, but kind of best practices like you define source, then your staging tables will be there. If your kind of requirements or use case are complex, you will have incremental model. Not complex, I mean, if requirement is there to increment model, means refresh the data. We'll just discuss, I will explain what is this and all, then we'll have MOT model. If it is very simple, you will have one staging model tables and simple MOT model where your for us customers are nothing but Tableau team, right? Tableau team will use that MOT model. So staging model means it is a kind of one-to-one relationship with source tables, because suppose take order table is there from source side, customer table is there. It is kind of staging model will just define as a kind of one-to-one relationship, means we get the we just take the same data in staging models, but we do slight or light transformations. For example, like uh, ID, right? Customer, you're getting a data from source. Just think like a two tables, like one is customers table and the other one is order table. Just to give you example, we are getting data from different sources. They are just using as a ID, okay? But you will not understand whether it is a order ID or customer ID, right? That's what you need to do, that light transformations where you can change your columns, or casting means data type changes, or any basic conversion, probably some value to value like USD to IN or whatever. Very minor, small light transformations can be done in staging models, but best practices, we should not do joins, means not to uh, we should not do joins in the sense that that is a best practice. We should not do aggregations in staging models. Okay, so materialization we should use as a views instead of tables. It is only just for cost saving purpose, because if you do it in views, you will save little cost. Again, it depends. We need to see our particular use case. What is our requirement? We need to understand our data model completely, right? Based on that, we need to do that. But this is what the best practice. So do we understand why we should not do joins and aggregation in staging models? It is just a simple model where aggregations and joins will be coming in other models, where after that, probably you all know little data modeling, right? How actually they're in Snowflake, correct? Are you all following with me?
Yeah, yes.
Yes, yes,
right?
Yes.
Okay. So it's incremental model. It's again based on use case, whether we need to refresh the data. That's where this use of incremental model. Sometimes if it is a very large data sets or complex environment, we'll use that. It based on requirement. In fact, it's not really whether it's a big or small large data sets. So because if it is a small data set, we can just recreate the table, right? We need not really worry. But where it will get lot advantages, if it is a large data set, we need not really create every time. We'll just update whatever the rows it's got updated. So we'll just check what is the last run we run this one. We'll just check any data changes are there. That's what incremental model use. First time model runs, the table kind of it's completely all rows, transformations will be done for all rows. Subsequent runs based on timestamp and unique key, it will just check whether any changes, right? That those changes only will be applied to your tables. So again, the strategy we use as a incremental materialization strategy. That's how that incremental materialization will be used in models. So same thing, like just to give you example, merge or delete, insert like Snowflake. So moving on, March model, it's this is what kind of final tables means. You have done small transformations. You done you need to apply business logic, where in the Mart model, because no need to do small transformations, you are kind of getting a data from two, three different tables or views. Then you whatever that logic related to business, we need to apply here in Mart's model. So it can be joins, it can be aggregation. So whatever it's, we cannot do it in staging model. Not cannot means it's not best practice, right? So whatever it is there, we should apply all those aggregation and everything in Mart model. So Mart model, what are the tables created through Mart model? So that's how reporting team or Tableau team or visualization team, right? They will use these tables created in Mart models. It's kind of a final. That's how, I mean, if you understand data model, this is how, right? Source, then staging, then Mart model. So it will go to downstream, like whether it can be data science or reporting, whatever. Okay, is it clear?
Yes.
Yes, Raju.
Okay, cool. So the other kind of another concept called seeds. Why do we need seeds? Just to give you example, for example, you're kind of working on some use case, right? Sales related use case and all. You get all whatever history or what current sales and all getting from multiple tables. But suppose your sales team need to give you that every quarterly sales target. I'm just giving you example to understand seeds. So they will give in CSV file. It's kind of quarterly sales target, right? So you need to just upload that sales target file separately. That can be CSV file. So that's how seeds, whatever that kind of use cases will do through seeds. So it's basically CSV files that can be loaded to our data warehouse. It's basically suited for smaller or static data sets, means very like this example, right? It is very small because it's only just sales target. Store wise will not really deal lot data. Or the other example, suppose your country regions table, right? Every time this will not change. So these data you will keep in one table, very simple, small table. It will not change regularly, right? That's how that kind of a particular requirement you will handle through seeds model. So you will upload that by using seeds model. I mean, but the only difference is it's kind of you can upload through CSV files. So uh, basically it is reference data and lookup tables, what I explained so far. It's kind of can be sales related data or anything, just to give some examples so you will understand better. So these are kind of important concepts regarding modeling and all. Okay. So this is another powerful features in Snapshot. Okay, so I don't know what's your experience SCD type 2 in your project so far. Some use cases really they want to track all the changes, because for them, for some use cases it is very important to track the complete changes. It's not just a replace the table, because that replacing table will not work. We need to have the complete history of changes. Okay, so that is very common requirement in most of the use cases. What we do usually in if we are not using DPD, probably we'll just handle by writing some custom code in Snowflake, or some tools probably will provide that SCD type to talent, and some tools probably they will give, but some piece of code I think we need to write and all. So that is the another powerful feature, means kind of out of box feature provided by DBT, where you will have a snapshot feature. It will record changes SCD type 2 basically, where you can create snapshot table when you run DBT snapshot command, where it will have some additional columns will be created. DBT valid from DBT valid to dates, means two additional columns will be created. Means what is that data validity, right? What dates it's valid from valid to. It's this concept basically uses strategy, timestamp strategy, like what is that last timestamp this data got changed. So this is the recommended timestamp strategy, because we are kind of able to do that setup. What setup means, what strategy we want to follow to record the changes, right? So timestamp is always recommended, but in your particular use cases, if you don't have correct timestamp, or you cannot use the timestamp for SCD type 2, then probably you need to just check, you need to use that check strategy. That is nothing but we need to identify what columns we can just use for this SCD type changes. So just this is how your code will be there, where you just simply write, as I discussed yesterday, the Jinja template, means this is how very small piece of code we'll write where we'll just write target schema, means it will be another table, snapshot table will be created under a snapshot, where what strategy we'll use, whether preferably timestamp strategy, or if you want some other strategy, probably we can use that as well. So we need to understand our use case requirements, what exactly we need, and what is available, right? What is our source tables and all. That's how we can just do that. Okay, so any questions?
No.
Are we good? Okay, cool. Kind of the next very important, very I mean very I would say very good, highly good feature, tests. Okay, so DBT has a framework. It can test your models and data sets. So again, if you don't have the feature in Snowflake, if you want to do that, right, maybe we need to depend on other tools, where data quality tools, even nowadays, your AWS Glue also provides some kind of a data quality related stuff, that kind of testing. So test need not be, I mean, not restricted to only just data quality, it can be anything. So out of box, DBT will provide 4 tests. One is one test will check whether your column, you are getting unique data, or your column containing any null values. All right, so that's how your test will check, and accepted values contain certain values. For example, status should be only approved or submitted, right? So if you give that values, only just it should have only certain values, maybe 4 or 5 values. It will just check whether that particular source data, whether has that same accepted values, or it suppose values different than what values you have given, it will fail that test case. Okay, it will give you that what data I'm getting, it's not correct, because I'm just getting some values, not accepted values. And again, it also will test relationship. If you are kind of mentioning kind of, this is how my tables relationship, right? One this is a primary key and the other one is foreign key. So this is how my relationship should be. Then you can define, okay, this is how relationship ship should be there with foreign key and primary key between tables. Then this particular test will test whether complete data model following that relationship or not, wherever you define, right? So if it is kind of satisfied, it will pass that particular test, otherwise it will fail. Then you will know, okay, something is wrong, right? Whatever the data I'm getting from source, it is not really good, something is breaking. At the same time, you also write some custom test cases on your own requirement. That test also you can just apply to source. So I will just show you in screenshot, you will understand. Okay, so this is about tests. Then moving on to documentation. Again, this is also another very good feature. Why I'm just saying, because in some of the projects I used to write in Excel. Okay, so what is my column names? What are the data types? And so I used to, because we need to maintain center place, right? So I used to write in Excel. I used to put it in some Word and all, right? So it is very tedious. Maybe some tools or some database probably provide some documentation, maybe some, or we need to depend on some other tools to get the documentation. So this has kind of inbuilt feature where anyone can access that documentation. Once you generate, it is not really not any data scientist or anyone can pick up that documentation. And also you can just control your how that documentation, you can just define those things. I will just show you that also, you will understand. So where you will get complete column and model level descriptions from ML file, and column names, types, and the table statistics like when it got last modified, who is the owner for that particular table and all. So these are the details you would get from documentation feature in DBT. Okay. So any questions before we move on to just kind of few screens where I will explain? Are we good?
Yeah, yeah.
I'm good.
Okay, cool.
You mentioned that incremental load model right now, that is nothing but is like a lookup transformation.
Lookup transformations means what? What exactly you mean by lookup transformation?
So whatever the data that we come, fresh data will be loaded, or like how the mesh statement will work, like that only it will work.
Exactly, exactly. So to give you example, what for example, you have orders table, right? You are getting daily orders table from, because it is a kind of a very it's a daily changes will be there, right? You're suppose just I will explain you. Order table is there, you are getting data from daily from order table. Okay, so today you have 1,000 orders. One order status is then submitted, one order is approved, one order delivered, right? You have 1,000 lines of the in your table. You are clear, right? So tomorrow some orders data got changed, submitted to approved, approved to delivered. Okay, where 900 rows probably there is no change because it's all old orders, right? Maybe
Yes.
changes done 100, right? So
Yeah.
there are two ways, right? If you want to just create a data model, you are getting the data where you have two options. Again, today also you got 1,000 rows of data plus suppose 10 new lines.
Some updated records
Exactly. You
also.
can create table completely with today's data, or you can just this refresh, right? Merge in Snowflake. You have that two
Yeah.
options. You can use merge where it will just check whether any data is changed. Then it will, any rows got deleted, it will delete it. Any new rows got added, it will add. If any status, if something is changed, it will change. So that's how your incremental model also it will work. So wherever you have that particular use case requirement, you can define that one. So instead of defining, you will just mention as a table and views. Instead of table and view, you will mention as an incremental model. So then it will pick up that code from DBT. It will just work in an incremental model. Okay, clear? Yeah.
Right.
Okay, so any other questions? Anyone? Okay, so anyway, I mean, we are going to configure everything, but this is how our demo screens probably. This I created for on customer demo and all because we cannot. So this is what DBT tool where kind of some tabs like version control. It is directly integrated with Git, where we will see file explorer. We discussed, right? This is I mean few concepts also there. I don't want to kind of explain everything. You will get confused and all. So whatever I discussed, it's kind of a all critical important where majorly we use features. So once we kind of comfortable, once we have requirement, probably we can learn other things as well. But for now, I think this is more than sufficient. So models we discuss, right? DBT packages we discuss, so we get that. Then seeds, snapshots we discuss, then test we discuss, project ML packages same. And so this is how where we run commands, DBT run and all, where you seeing. So then kind of navigations anyway will show you. You will be able to understand better once we see that. So source I already explained. So this is how you write a test, right? You need not write, means how simple, just see test unique, that's it, it is done. So if you just written this piece of code, this is what we discussed, right? The out of box features. If you just give this unique not null, it will execute all these test cases, unique not null test cases against this orders table, because we defined it in source directly. So every time if you are getting data, it will just validate whether that whatever the key you are defining, right? We are just defining an order key, whether is it unique or is it a not null. If it's kind of not satisfying these two tests, it will give you the message. It will give you the information these tests failed. Then you will you will go and check why it is getting, you are not getting, right? So to give this test, I mean, we need to understand our complete use case. We need to understand our client requirement. Then based on that, we can just do this one. So staging models, this is how you will define your staging models, where suppose you are getting a columns like order key, where you just do slight transformations, customer key as a customer key, okay, clerk as clerk name. So this is how you do small transformations, where in mainly in staging models. Why it's not moving? Okay, so this is how we run DBT, run commands and all. This is how it will execute, means what models we execute. So we'll, once we see, we'll understand. So this is how, suppose raw data, we are getting raw data where we have not done any transformations, where order key or customer key order status, where there are no transformations before transformations. This is our columns. After transformations, because you apply transformations in DBT, this is how your columns change, order key, customer key, by using your staging model status code, right? And this is how tables will be created, but I will show you once that started. This is how we can see lineage, where what is my source orders and what are that intermediate staging and what is that mart models and all. Finally, what is that fact models and all. Okay. So by just using this function, you know, means how that data is flowing between right from source to your in Tableau. So then we can run tests. I've shown you, then it will give you like this test accepted values, and also this is how you will know what test passed, what test failed, why it is failed and all. Then this is how DBT documentation, the system will generate, where you will be able to see what are the columns, order key, customer key, and what are that column type, and description. If we are giving description properly in our files, you will get description for that file as well. So then what test it's got executed and all. So these all details you will get in DBT documentation. So DBT documentation can be accessed by kind of all teams, right? You need not again download and share. They can just come and check your DBT documentation. Those teams need not come to you like what is this column, what is that data type and all. So they can just go and check your documentation directly. Okay, so this is what theory. So then, as I said, okay. So introduction features we're done. So next 4 sessions we are going to do these 4 labs, where setups, and we'll take one use case, we'll execute that, we'll create some models. Now you understand better since yesterday, because yesterday probably you're very new, now you know all these terms. So in lab 3 we'll execute that mart models, reference function. Final day we'll just do test, document generation and all. Okay, so yep, I think that's all. Kind of we covered maximum almost all features. I would say if we are comfortable with this thing, at least we are kind of 90% good. Any questions?
No, Raju.
No, Raju.
I'm good,
Okay.
Raju.
So I just kind of currently creating these lab guides because lab guides kind of a you need all detailed steps, because if I explain one day and probably it's kind of you will miss everything. So what I'm just planning, so I'm just creating some detailed steps in each and every lab guide. So I will give you that lab guide. So right, I will explain how to execute that lab, and you follow that steps in lab guide. So you'll be able to execute that use case right from source to complete mock. Okay, cool.